Hello students, I Rohit Shah, Assistant Professor in Shyamlal College, is back with the fifth lecture of Mathematics of Finance. The topic that we are considering today is depreciation. Depreciation is the regular wear and tear in the value of the assets, precisely fixed assets. There are ample number of methods by which we can charge depreciation, but here we will limit ourselves to only three methods. The very first method of charging depreciation is straight line method. Therefore, the formula for annual depreciation becomes D equals to cost minus scrap value divided by the life of the asset. The second method of charging depreciation is sum of the year digit method. In this method, we assume that higher depreciation is charged in the initial years, and total depreciation is divided between the years in the ratio of time left. So let's try to understand this method of depreciation via example. So here in the question, a machine costing rupees 30,000 having useful life of 5 years and 0 salvage value. We need to find annual depreciation by sum of the year digit method. So how do we do it? First we find the total depreciation. So total depreciation is equals to cost subtracted by salvage value, which is equals to rupees 30,000, as we have no salvage value in the given case. Now we make a table to compute the annual depreciation. So the table looks something like this, in which we compute depreciation schedule of year 1, 2, 3, 4 and 5. Here we will be writing the ratio, and here we will be computing the annual depreciation. The ratio of charging depreciation is found by writing the years in reverse order: 1, 2, 3, 4 and 5. Now we find sum of the years. Sum of the years is 1 plus 2 plus 3 plus 4 plus 5, which makes it to 15. So now we divide here by 15, every item here in the ratio by 15. So we get the ratio. Hence the first year depreciation is in the ratio of 5:15, second year depreciation ratio is 4/15, third year depreciation ratio is 3/15, and similarly for fourth year and fifth year. Now we compute annual depreciation. The formula for annual depreciation is total depreciation multiplied by the ratio. So this becomes 30,000 multiplied by 5/15, which makes it to 10,000. Similarly, we will compute for all 5 years. So after solving, we get depreciation for second year to be 8,000, for third year to be 6,000, for fourth year to be 4,000, and for the last year to be 2,000. Hence, these are the annual depreciation that we would be charging every year. The third method of charging depreciation is written down value method. We also know it by the name of diminishing balance method or constant percentage method. In this method, a constant percentage or a fixed rate is charged to the previous year written down value of the given asset. Therefore, the formula for finding the value of the asset at the end of nth year is cost multiplied by 1 minus r to the power n, where n is the year for which we are finding the value of the asset, Sn is the value of the asset in nth year, C is the cost of the asset, and R is the annual rate of depreciation. So let's try to understand the concept of WDV by a question. A mainframe computer whose cost is rupees 5 lakh will depreciate to a scrap value of rupees 50,000 in 5 years. We need to find the book value of the computer at the end of third year. First by straight line method, and then second by WDV method. So in straight line method, we all know that annual depreciation is equals to cost minus scrap divided by useful life. Therefore annual depreciation becomes 5 lakh minus scrap value, which is 50,000, divided by useful life of the asset, which is again 5 years. So 5 lakh minus 50,000 divided by 5 and we get the value 90,000. Therefore annual depreciation by SLM method is 90,000. Therefore book value of computer at the end of third year would be cost, that is 5 lakh subtracted by depreciation for 3 years. Which makes it to 5 lakh minus annual depreciation, which is 90,000 multiplied by 3, and which makes it to rupees 2,30,000. Therefore book value of the computer at the end of third year will be rupees 2,30,000 if straight line method of depreciation is used. Now the second part of the question says that to use Wdb method. In Wdb method we know that the value of asset at nth year is equals to cost 1 minus depreciation rate to the power n. So the value of asset at the end of third year becomes cost 1 minus rate of depreciation to the power 3. Since we do not know rate of depreciation, we will not be able to compute the value of asset at the end of third year. So first we need to find the annual rate of depreciation, and then only we will be able to find it. We all know that the value of the asset at the end of fifth year is 50,000, which is the scrap value. Since S5 is equals to 5 lakh, that is our cost, 1 minus rate of depreciation, that is R, which is unknown, to the power 5, which implies 50,000 is equals to 5 lakh 1 minus R to the power 5. Now we will divide this 5 lakh here, so this becomes 0.1 is equals to 1 minus R to the power 5. Now we will apply log on both the sides, so this becomes log 0.1 is equals to 5 log 1 minus R. In the earlier classes I mentioned that we cannot find the value of log having less than 1 digit before the decimal directly, so we will use the indirect method here. So the indirect method is we will divide this by a number which should be in the multiples of 10. So I divide this by 10 equals to 5 log 1 minus R. So I can rewrite it as log 1 minus log 10 is equals to 5 log 1 minus R. The value of log 1 is always equals to 0. The value of log 10 is always equals to 1 is equals to 5 log 1 minus R. So we will divide 5 here, so this becomes minus 0.2 is equals to log 1 minus R. Now to eliminate log from here, we multiply both the sides with antilog. So this becomes antilog minus 0.2 is equals to 1 minus R. Antilog multiplied by log here gets cancelled. As mentioned in previous classes, we cannot find the antilog of any negative value directly. So we use the indirect method here. How do we do it? So how do we find the antilog of a negative value indirectly? In this method, we find a digit which is just higher than the value given here, eliminating the negative sign. So the value which is just higher than 0.2 is 1. It should be a whole number, it should be a digit. So the value which is just higher than 0.2 is 1. Now we subtract 0.2 from the obtained digit. So what do we get? We get 0.8. Now in this 0.8, since we have borrowed 1, so we write it as antilog of 1 bar 0.8. 1 bar indicates that we have borrowed 1 to make the given digit positive or make the given value positive, and as we have made the value positive, now it is positive 0.8 and 1 borrowed. So now we find the value of 0.8 in the antilog table because we look only the digits after the decimal. So in antilog table in 0.8 we get 6310. So we write here 6310. No need to add anything because we don't have any further digits here. Now we will apply the same logic of putting the decimal point in 6310. The logic was the value just before the decimal, here it is -1, plus we needed to add 1 which makes it to 0, hence the decimal will be put after 0 digits. So the decimal point would be put here, so this becomes 0.6310, which means that the value of antilog -0.2 is 0.6310. I hope this is clear to all. So we write here 0.6310 is equals to 1 minus r. Therefore we get the value of r is equals to 0.369 or 36.9%. Therefore book value of computer at the end of third year is equals to S3, cost which is 5 lakh, 1 minus r which is the depreciation rate or annual depreciation rate which we have calculated to 0.369 to the power n, which is 3. And after solving this we get the value as 1,25,620 rupees as the value of the computer at the end of third year. I hope this is clear to all.